Okay, so here is the first question, 1 mark section, question number 1. The question says the functional groups present in propanol and propanal are dash. Propanol, so let me write this here, propanol and propanal. Can you tell me what could be the answer? Option A, B, C or D? Okay, see, in the question itself we have the answer OL and here AL. So these are the suffix added, OL for alcohol and AL for aldehyde. Got it? So alcohol functional group, it is a functional group, its formula is OH, and aldehydes is CHO. Got it? So based on these two names itself, you are going to get the answer. So here the options are OH and CHO. It's there in the option A itself. So our answer is option number A, OH and CHO. Got it, guys? Are you getting it?
Yes, sir.
Okay. Yeah, fine.
Yes, sir.
So let me tell you some more things related to this. Before that, I'll mute everyone. Yeah, see. So other than these two, you should also know about carboxylic acid, then ketones. These two are also important. So for carboxylic acid, the formula is COOH, and for ketones, it is just CO. Okay, and the suffix is oic acid. It could have been propanoic acid. Okay, and for ketone, it is ONE. It could have been propanone if it was ketone. So you have to look at the suffix in the question. Got it? So these two also you try to remember. Are you guys getting it? You can just give a thumbs up if yes. Okay, so let us move to the second question. I hope you have understood this. Okay, so second question is from physics chapter light. Okay, so you can keep your book ready. I'll be mentioning you the page number. Okay, see, the question is to obtain a diminished image of an object from a concave mirror, the position of object should be, okay, F is focus, C is center of curvature, P is pole. Okay, what should be the position of object, either between C and F, beyond C, between P and F, at F? This is the question. Okay, so here the mirror is concave mirror. So if I draw, it will look like this. This is concave, okay, mirror, not lens. And this side we have reflecting surface. I'll write RF. This is pole P, which they have mentioned here. Then we have F, that is principal focus, and this is C, center of curvature. So object will be in the left side. Okay, now to obtain a diminished image, what should be the position of object? Okay, this is the question. So if you have your book, I will ask you to open this table 10.1. I don't know whether it is 10.1. The book which I am having, it's in page number 164. It is from the light chapter, The table is image formation by a concave mirror for different position of objects. Okay, if you have textbook you can open, or else I'll just explain it here. See, so to get a diminished image in the concave mirror, diminished image, you have only one option over there. The object should be just a minute, beyond C. Okay, it will be somewhere near C object. Only if it is here we are going to get figure something like this if I draw it properly, but this you are not going to get roughly. You have to draw it using scale, only then you will be getting. But you try to behead the table of chapter light. You have 10.1, that is for concave mirror, and one more is for convex lens. You should behead them both. Okay, it is 10.4. If the chapter number is 10, then it will be 10.1 and 10.4. These two are very important. Here the answer is beyond C, option number B. Okay, this is the answer. Next, third one, the question says the electronic configuration of X is 2881 and the electronic configuration of element Y is 287. Then the type of bond formed between these two elements is dash. Okay, see, this is 2881 and the other is 287. It means this is complete shells 288. This is in the outermost shell. Okay, it's extra. One of the electron is more here. This is filled shell. Again, this is filled, but here it is incomplete shell. So here it should be 8, but there are only 7 electrons. So these electron which is in the first, it can come here, and even this can become 288. So which type of sharing is going on here? It's between metal and non-metal. Okay, so the sharing of electrons between metal and non-metal is called as what? Which type of bond you are going to get? Covalent, hydrogen, metallic, or ionic? It is ionic bond. Okay, because we are going to get ions here. Okay, this will be in the form of minus. For example, Cl minus, Na plus. So the answer is ionic bond. Got it? Are you guys getting? Okay, next is one mark question. Name the acid present in the stinging or stinging hair of nettle leaves. Okay, so this is from the chapter acid, bases and salt. See, I have given a table here. It's from your textbook itself. So this is very important table. Try to behead it. Okay, the acids present in different sources. Okay, so they have asked nettle leaves, nettle sting or leaves, both are the same. The answer is methanoic acid. Okay, if they ask you about lemon, it will be citric acid, vinegar, acetic, orange citric. Try to behead this properly. So this has been asked many times, that is nettle leaves or ant sting. Both of them have methanoic acid. So this is a 1 mark question. I hope you have understood this. Okay. Okay, fine. So now question number 5. What does it says? Question number 5 is convex mirror is commonly used as rear view mirror. Okay, then full stop. Why? So what could be the answer? This is for 1 marks. So you can just write like this. Convex mirrors are commonly used as rear view mirrors because you can give points wise. Because first point, they always give which type of image? Convex mirror, because they always give erect and diminished image. This is first point, diminished image. And the second is, second point can be they have a wider, they have a wider field of view as they are curved outwards, as they are curved outwards. Okay, so you will get half marks to each points. Okay, this is very important. Even if you write just 1 point, and don't think you will get full marks, you have to write both the points. Got it, guys? Are you guys getting it? Okay, fine. Coming to our next question. Question number 6. What is roasting in metallurgy? Okay, so this is from the chapter metal and non-metal. So these two definitions are very important. One is roasting and the other is calcination. Okay, so these both methods involve conversion of some compound into oxides. So I'm just giving you one clue how to buy them. Okay, what is roasting in metallurgy? See, oxides, and this is for sorry, this is also we are going to convert into oxides, but this is carbonates. This is for carbonates and this is for sulfides. Okay, so you can write answer like this: the process of hello, hello, yes, are you guys there? Okay, there was some issue. Okay, see, the process of, or the process by which sulfide ores are converted into oxides. Sulfide ores are converted into oxides by heating strongly in limited air. That is called as, what is that? For roasting, it is the process by which sulfide ores are converted into oxides by heating in the presence of excess air. In the presence of excess air. So this is roasting. Calcination is same, the process by which carbonate ores are converted into oxides in the presence of, here you have to write limited air. This is for limited air. Okay, so how to remember? See, here in calcination you have letter C, in carbonate also C. So using both C you can just remember, if it is calcination, it is carbonate into oxide, and if it is roasting, it is sulfide into oxide. Got it, guys? Have you understood? So try to remember with this form: calcination for carbonate and roasting for sulfide. Both of them are converted into oxides. Okay, roasting in the presence of excess of air, calcination in the presence of limited air. Okay, now coming to the next question. Question of 2 marks each. So these all are also very easy. Let us see one by one. So seventh one, draw the diagram of electric circuits in which resistors R1, R2 and R3 are connected in parallel, including an ammeter, a voltmeter, and mark the direction of current. So this is for 2 marks. Okay, so I will just try to show you the figure. Okay, you can just look at it. It is from the chapter electricity. Okay, so these are the resistors R1, R2, R3 connected in parallel. Okay, and parallelly we have voltage, that is voltmeter here. You have to mark the sign as well. This is battery. Okay, plus and minus terminal is very important, and the sign of current, that is I refers to current. Okay, then you have ammeter. It will always be connected in series, and the direction is very important. Don't write here plus and minus. It's minus and plus. It's also there in your book. You can refer it from there as well. So for diagram we have 1.5 marks, and for parts just half. Got it? So you try to learn for series connection as well. Even that is very important. Got it? Are you guys getting? Okay. Now coming to question number 8. So what is the 8th question? The question says, what are structural isomers? What are structural isomers? Name the first member of alkane that shows structural isomerism. So what are structural isomers? Structural isomers, it is from the chapter carbon and compound. Okay, so let me show you this figure first. Yeah, so both of these are butane, correct? The name is butane. Its formula is C4H10, but it has two different structures. Got it? So the answer will be, what are structural isomers? Compounds with same molecular formula. Okay, the molecular formula is same. Compound with same molecular formula but different structures. This is very important. Same molecular formula but different structures. Compounds with same molecular formula but different structures are called as structural isomers. This is the answer for the first question. Next, the sub question is, name the first member of alkane that shows structural isomerism. So answer is butane. Only you can write butane or C4H10. Okay, no need of writing this diagram for this question. They have asked only the definition and the first member of alkane which shows structural isomerism. So it is butane, which has the same molecular formula but different structural formula, and it is the first member of alkane group. Got it, guys? Are you guys getting it? Okay. Coming to the next question. Question number 9. Again, it's diagram. Here the question is, draw the diagram of arrangement of apparatus used to show the reaction of zinc granules with dilute sulfuric acid and testing hydrogen gas by burning. Label the following parts: soap solution and delivery tube. So this is the diagram. It's there in your textbook as well. You can refer that and draw. Okay, no need of doing coloring and all. You have to just mark what they have asked. It is, sorry, soap solution and delivery tube. Yeah, see, even if you write like this, you'll get full marks. The diagram, you have to write only the delivery tube and soap solution. No need of mentioning other parts. Okay, again you will be getting 1.5 for diagram and half for the parts. Only these two parts you have to show it in arrow. Okay, here soap solution is here and delivery tube is here. Got it, guys? Okay, fine. Coming to our next question. The next question is question number 10. So the question says, according to Joule's law of heating, mention the factors on which heat produced in a resistor depend. According to this law, write the formula used to calculate the heat produced. So Joule's law of heating, again from the chapter electricity. It is this formula: H is equal to I square R T. Okay. See, if you know the formula, you can write the factors as well. Mention the factors on which heat produced in a resistor depends. So where, what is H? H is the heat produced. Okay. And what about the other parts? R. R is resistance of the conductor. T is time for which heat current is supplied to the conductor. Got it, guys? So this is formula. Now the factors, how are you going to write? You can write like this. See, factors on which, just follow this, factors on which heat produced in a resistor depends are, first one, here it is I, right? So you can write like this: the heat produced is directly proportional to the, what is this, square of electric current. First point. Second will be, it is directly proportional to, again, R. R is what? Resistance. Resistance of a given current. And third point, it is directly proportional to, again, time. Directly proportional to the time for which current flows through the resistor. Okay, if you refer the textbook, it's written there properly. So just if you know this formula, you can write this: the heat produced depends directly on the square of current, directly on the resistance of the conductor, and time for which current flows through the resistor. Instead of mentioning conductor, you mention resistor. Got it, guys? Are you guys getting it? Okay. Now coming to the next question. 11th one, and after this I will be stopping it here. The rest questions we'll try in our next class. The question is, draw the diagram of apparatus used in electrolysis of water and label the following parts: graphite rod and cathode. So again, this figure which is given in your textbook, you have to write. Okay, you have to mention only what they have asked, that is graphite rod and cathode. Okay, you can look at this as well. Yeah, this figure, I hope it's visible. Okay, this is I have taken from the solutions provided by the board. Even if you write this diagram and if you mention cathode and graphite rod, that will be more than enough. And you have to write its name. What is the name? Electrolysis of water. Got it, guys? Do you have any doubt?